मैं आपको process లో ఏమన్నా
Okay, done.
ఎందుకంటే మీకు 10th బీటెక్
బీటెక్ ఫైనల్ ఏ సిఎస్సి ఏ
Hi everyone, very good afternoon. Thanks for joining in for today's session. Today we have with us Mr. Kedar and Ram Verma from Tata Consultancy Services, who will be delivering the content for database and database structures. Sir, we extend a very warm welcome and a sincere gratitude for you to be a part of this session and providing valuable insights and exposure to the grand finale participants of Smart India Hackathon 2024. Over to you, sir.
Yeah, thank you, Abhishek.
फोर में से एक डुप्लीकेट आ total. Okay, the 100 confirm you're saying.
किसी भी
Kedar, sir, request you to kindly mute yourself with the option adjacent to start video. We have made you the co-host, sir.
Hello.
Yes, sir, you're audible, sir.
Yeah, I have joined from my mobile phone. Actually, that was not planned, right? Sorry, guys. Sorry for the technical hitch, but I should be able to speak from my laptop itself. I don't know what is happening.
No issues, sir. We can.
I'll share my screen. Yeah, go
Sure,
ahead,
sir.
Abhishek.
Sure. No issues, sir. You can present via mobile device as well. We can continue the session as per your convenience, sir.
Yeah, but the problem is the mobile battery goes down, then there is a problem, and I'm not able to unmute also from here,
Okay.
right? So just see, I mean, a minute more, but I'm sharing my screen. See
Sure, sir.
what is the problem. Yeah, I'll share my entire screen.
Could be 394048.
Yeah, there's nothing, no mute. Are you able to see my screen?
Yes, the deck is still loading.
Yes, we can see it.
Yeah,
Yeah, yeah.
correct. Yeah, so there's no mute, unmute button. Nothing is over here, and this just keep coming. I don't know how to remove it also. I don't want to. Yeah, I think that's the. I don't want to go into. Abhishek, if you are able to, yeah. Now I think this will go. Shall we start?
Sure, sir. We can start the sessions. Yeah.
Yeah, but then I really do not know when this battery goes off and I'm not able to unmute. So whatever you are telling me on the chart, the unmute button, there is no unmute button over here. Okay, so anyway,
Okay,
I'll
so I
share
guess
my.
there's some
Yeah.
technical glitch. Maybe because we have sent the request to unmute you. So
No, there's no. Anyway, let's start. So I'll share my. Yeah, I hope I'm audible now.
yes, sir. Yes, sir.
Yeah, thanks. So let's start. Starting little late, but let's go whatever 16 with whatever we can cover. So I'm Kedar. I'm working in data consultancy services for last 17 years now, and before that also I was working in abroad for almost 10 years. So I have a 25 plus years of experience. Let's start with why data structure. First of all, what is the need of a data structure, or rather technically why data structure? If data structures are not there, what will happen? So let's start with writing a function. I assume uh, most of us on the call, they are aware of what is a function, and they have some background to the computer technologies and the programming languages and all. Right? I don't expect a very deep knowledge of that, but at least to start with just the function. And who are having a knowledge, they might feel this is at the very basic level, but I've tried to cover from kind of ground level to mid level, so that everybody understands it. So let's write a function returning a square. It is just, so ignore all other messages that is coming up. So this is the function I have written. My function name is return square, and I'll be passing value I. So this function will just take that I. I will be multiplied by I, and it will send back. So that is how the function is, and then I will be calling that function as in my other what is my main program. I'll be asking the value of I, and once the value is entered, like I'll store that in the variable I. I'll give a call to return square, and whatever the value this is sending me back, I'm printing that as square, and the actual square that I get it. Let's try doing it. It is asking me enter value. I enter the value 3. It is giving me square 9. Yeah. I mean, don't look at the whether what function is this, and what are the formats and all. The point is not that. The point is something that the point that I want to derive is it's coming up. So don't get into like why that and is there, and why some certain things are in red and all. Point is not that. The point is now the next time I'm entering the value, I'm entering the value 3 instead of number 3. I'm giving it as a text 3. And Abhishek, are others able to speak on that, or they're on mute? They'll continue on mute.
So we have kept
Okay.
the audience, I mean the Smart India Hackathon Grant Finale students mute for the time being. In the
Okay, not
last
a
10 to
problem.
15 minutes, we'll, yeah.
Unmute them, not a problem. Yeah. So
Yeah.
clearly, this is going to give error, but why this error? And that is why actually we will get into our subject. What is the difference between 3 and 3? So data has a type. 3 is a number, and 3, when I write 3 or anything that has a text, is a text. So there are different types to the data, and when it comes to computer, each data type or each data is considered in a different way, and that is why let's see what happens in the memory when we call the function. So when the code is invoked, whatever we just saw some time back, the executable is loaded into the memory. Since I asked for variable I, the space is reserved to store the value of I. I've given the value 3 in this case. So this is the memory representation that is happening inside. So if you see this line, are you able to see my cursor? Abhishek, you can answer.
Sir, I guess you have stopped sharing a screen, sir.
Oh, is it? No, I
Yes, sir.
haven't.
We're
It
not
is
able to,
loading.
yeah.
Is it loading? I think it is loading. Or shall I start again?
Sir, I
Start
guess
again.
it's still loading.
Okay. I'll start again. I will share it again. Yeah, it has stopped. Let me know
So
when
we
you're
can
able
see
to
the
see.
screen. Yeah.
Yeah, okay. So that this we saw, this function also we saw. So when this code was invoked, the executable was loaded into the memory. Since the variable I we used, there is a space that CPU reserved the space for us in main memory, and the value 3 was given. So what happens inside the memory? Abhishek, please answer me. If are you able to see the cursor that I'm moving on the screen? Hello.
Oh, yes, Kedar. It's
Yeah, good.
visible to us now.
Yeah, correct. So these are the addresses. Addresses are actually not stored in a very simple way. It's not 1, 2, 3, 4 or 1, 2, 3, 4, 5 and all. Those are hexadecimal numbers. But here again, don't go with the sanctity of whether the addresses are given like that or the memory locations are like this. It is just the pictorial representation of the memory. So what we need to do is we need to just conceptually understand what is happening inside the memory. So when I ask for memory for a one variable, it was given that 1236 was the memory location given to my program. And when we enter the value 3, the value 3 was stored into the memory. So then once the memory location is given, the value 3 was given, and that value 3 cannot actually hold the value of THRR, the THREE. Obviously, it cannot. If at all we want to do it has to be done like that. Again, uh, the guys who are understanding it or deep into the computer science, it is not that easy. We just can't store 3 and 3 like that. But again, as I told you, the point what I want to make over here is different data types keep different sizes into memory to store. So 3 and 3 have two different sizes. The questions are there. Can we use it when I'm utilize it for number 3? Can I utilize the character 3 over there? Obviously, answer is no, and that's why that error was given. But the point over here is there are different types of data types, and I mean there are different data types, and each of these take up different memory locations when they are stored into memory. Again, the second thing, why those data types are needed. Example is like number can be added, or then arithmetic operations can be done only on the number. Like 5 plus 4 equal to 9 is possible when both are number. Concatenation is possible only with the string. I love, and if I concatenate that with India, I love India makes a meaningful sentence. But if I try to do 5 can concatenate with 4, and if I'm expecting answer 54, if 5 and 4 are is used as a string, that is possible. But if it is used as a number, that is wrong. It should not happen. And that's why these data types are also required. So two things. One is the operations that happen. Those are separate on the different data types. And the memory locations, the storage memory locations are also different for different data types. Yeah. So this is just an example. This is not an exhaustive list of complete data types and the memory sizes. But character takes 1 byte, and the example is A. When I say 1 byte, the modern machine and the old machine, there are different. It goes the root goes into the process, whether 1 byte or 2 byte is a bus and all. But going by general method or going by usual things, the A requires 1 character to be stored. Integers are stored into 2 bytes, like 54 are written into 2 bytes. Floats take 4 bytes. That's the example of 98.78. And strings take, it is a series of characters. So when I say India, it is stored as INDIA separately, and each taking 1 byte within it. Okay. Now let's have a look at the data structure. What are data structures? So data structure is a way of organizing data in order to use it in most efficient way. We'll see what we mean by most efficient way. But when we say data structure and data types, so these are the data types. These are kind of data types what we have. And when it comes to data structures, when it comes to data structure, Data structure is methods of organizing and storing the data. So I hope now it is very clear what is data types and what are the data structures. Need of data structure. Is it loading properly, Abhishek? I'm on the first point of need of data structure.
So we can see the deck,
Hello,
but
hello.
I guess it's paused.
What is happening here? Where it is paused?
It's moving now,
So
sir. It's
what is
moving now.
what? Come again, sorry, I missed that. What is it showing?
Sir, it's on what happens inside the memory.
Oh, I don't know what was the problem. Okay, I think I'll have to change my. Allow me a minute. I need to change my connection type. Looks like it is very slow. Hope it is faster now once I connect. Is it visible now? Abhishek, is it visible now?
Yes, sir. Sir, it's loading.
Okay. Let me know when it is visible. Is it loaded?
So we can't see the screen.
I don't know what is happening. I'll have to again and again do that. I say I'll do one thing. No, but if I come out of the meeting room, it will be a problem for you to set it again. Is it visible?
Sir, I guess you stopped sharing the content.
I don't know how to do that. I really don't know. What is the problem? That also I'm not coming to know. Abhishek, I think I'll quit and then I'll get in again. That's the only way of doing it.
Sure.
Hello? Are you able to see it now? Hello?
No, sir, we can't see the screen.
Okay, Ram, can you try? I think there is some problem with this. Somebody else can do it. Ram, can you try sharing something?
Yeah, sure. Let me try from my end.
Meanwhile, let me see what is going wrong. Or while you start, I'll then try to share and then see whether I'm able to do it.
Okay. Can you guys see my screen
Yes, sir, we can see your screen.
for the confirmation? Okay, so maybe let me continue. By the time Kedar gets his machine fixed,
Sure.
the thing. Good afternoon, everyone. I am Ram Verma from TCS. So I have around 15 years of experience with development and all those uh, things. So I'm just going to cover up here few of the things related to algorithms, like how data structure and algorithms are basically correlated and how we use them for developing the processes basically, right? Because when we want to write code or write any program for any of the applications, so those codes should be properly formatted, like the whatever instruction the machine. So those instructions are to be in the proper format and they should be properly controlled. So that is the main target when we try to write the algorithm using this one. So let me. Okay, so the main thing is like since we all are using nowadays computers to do all the operations and writing codes, and those codes basically helps to operate any of the devices, either it is we can say cars, like the auto driven cars, robots, any devices, even the cameras, mobile phones, everything. So for this to write the program, we need to provide step-by-step instructions to the machine, and those instructions are processed by the processor, and then we can see like how they basically perform any operations. For example, if we take this Vivek that we are using right now, right? So now it has a lot of controls in it available, which we are using. So when we click on a particular control or a button, it performs certain operations, either it is unmute or share the screen, or to put some text in the chat or highlight anything on that one, right? So those are the two things which are being performed using any of the programming language. So here I just want to say like when we write the program, so we need to solve some problem basically, right? Main target is like when we are writing or we are performing anything, our main target is to like that code should be performing something that should be helpful for the human being or for the any activity that we need to do. So to perform multiple, we can write multiple algorithms which can be designed to solve a particular problem. Then we have an algorithm that provides the maximum efficiency that should be used for solving the problem. So when we write the code, so if I say like most of the time we can see like the processors can be faster, and then the memory they are consuming where it is working. So those are the two main factors, or we can say the bottlenecks basically. That if you want to run any of your machine faster or the code to run faster, you need to basically track like how these code where it is running, so how much memory it is consuming, and the algorithm that you have written, how fast it is able to search or update data or get data from the location of the database. So those are the few of the things we need to keep in mind. So when we organize the data, and this organization part, which we normally call, right? So this data structure helps in creating programs that are simple, usable, and easy to maintain. This will, we are going to just discuss here, like how these things will be working and what are the different techniques we will be using. Write the algorithm, how to identify, like how fast the algorithm that we have written will be working, and what are the different factors affecting our algorithm. So let's move to the next slide. So basically, the role of a data structure and algorithm is used for normally for the problem solving. And here we are just going to identify how we will be writing the algorithm and how efficient that particular algorithm will be. And we say like the problem solving is an essential part of every scientific discipline, right? And computers are widely being used to solve problems pertaining to various domains, banking, commerce, medicines, manufacturing, e-commerce, transport, or whatever field we say. Right? Everywhere we are using these computers, which are actually helping us and sharing their our hands to solve the problems. The given problem by any computer we can write. So to solve any problem, we can simply write a program, and that program can be written in any programming language, whether it is C Sharp, C, C++, VB, Java, or anything. So those programming languages we can utilize to write and provide the instructions to the machines to operate and work on. So simply the algorithm can be defined as a step-by-step procedure for solving a problem that we all knows and understand, with how we can simply step and write all the steps to carry out the work. Then for writing the algorithm, we normally require these 5 different things, right? So if we control and we manage while writing the program, so like we can say for our program is finite, we have a definiteness, and we have a proper input that would be giving us the output and the how algorithm is effective to us. So here just try to explain in one step basically what to say. So what is finiteness means like a algorithm must always be terminated after a finite number of steps. So the concept here is like, since we have a program, like when we are writing the program, so there can be certain steps which we are actually iterating or repeating. So we need to put a control, like after how many iterations that program should stop, or those repetitions should not continue for an infinite time, right? So that is the thing which we want to proof from this finiteness basically. Definiteness means like each step in algorithm must be precisely defined, like what operation that step should be doing or performing. That has to be defined properly, right? And there should not be any ambiguity, like when we put any certain logic or condition, right? When we are doing the branching basically. So if we provide if else or while loop or anything which we are putting up there, so those things should be properly managed, and there should be a clear cut instruction. So that normally just Kedar was trying to see when providing the data type. So you are saying like, suppose if we input a value which is character, and in the code we have written a logic to identify a integer value basically or a float value. So when it input, it receives the input from there and it is not the proper data type format. In that case, it may fail or it will not work properly. So those things we need to keep in mind, right? And then comes the input, like when we are trying to process anything or the code that we have written. So that code should be giving some output, right? To give the output, it should have some input basically to process. So this is the main thing which we want to say. Like if you want to process anything, so we need to provide some data. So that data should be provided to the program, and that can be taken from anywhere. Either it is the text input, it can be image, it can be audio, it can be video, or it can be any data from anywhere, right? So that should be processed. And output will be what? After processing, whatever result or the solution we have got, that should be our output basically. And the effectiveness, like how fast the program performs and how accurate the result we have got, because that will totally depend on these different conditions which we have given to it. Whatever steps we have provided, what are the conditions we have given. So before actually writing the program, we need to be clear with our algorithm, that our algorithm should be clear and finite, that okay, it should be giving this particular result and these are the different steps it should be following. Okay. Let's move to the next slide. So there are different approaches which we are actually following to perform while writing the algorithm. So in addition, algorithm provides the following benefits, like it helps in writing the corresponding program because we know the actual steps, how the branching should be done, where the conditions should be provided, how many times the iteration should be done, right? Then it helps in dividing difficult program problems into a series of small solvable problems, right? This, I guess, since beginning of our school days, we might be hearing that it's like divide and rule, right? That's what we normally say. So it's like just break the bigger problem into smaller one. And in normal programming languages, we normally say like whatever we simply write programs or small functions, and then we combine all the small functions to perform a bigger operation. So that's why we are trying to see that we can simply divide a bigger problem into smaller ones, and then we can try to solve it. Then making decisions, and the process should be consistent and reliable. So whatever the process we are writing, it should not be breaking out or it should not be giving some unnecessary results. It should not be going to the infinite loops, or it should be giving out the garbage data. And after the process has run or completed, it should be clearing up all the memory it might have used or consumed during the processing time. So those are the few of the things which also we need to keep in mind while writing any of the algorithms, right? Then we have different algorithms which can be used to write a same problem, right? Because every human being, they have a different thought process. So to complete a simple program itself, like everyone has their own thought process. So they can have a different algorithm to complete the same process. That we normally see while we're doing the program or processing. It, some algorithms may solve the problem more efficiently than the other. It's always there because some codes are efficient and some code are less efficient depending on what type of data structure we have used, defined, and what are the algorithms we have used while writing it. So they are totally dependent on that one. And apart from that, there is one more dependency related to the processor and the time it's taken and the memory size where it is actually processing. So if the memory is more or huge, in that case, the performance may decrease. So that are few of the bottlenecks which we need to take up while writing the program. Then an algorithm maximum efficiency should be used to solve a problem. Kedar, you want to speak something? Vishal, shall I continue or Kedar want to continue?
Sure, sir. You can further continue the session since Kedar sir is facing some technical issues.
Okay, sure. So I will continue, right? Thank you. Okay, then data structure is defined as a way of organizing the various data elements in memory with respect to each other, right? So we need to actually keep both the things in mind, the time as well, like the time it will take to process the program or algorithm, and the memory, basically, right? So here I just listed few of the data which are normally used, right? These are, so we have arrays, keys, then we have text, keys, graphs, and they are basically used while organizing the data or trying to write the algorithms basically. So I have created few of the examples to show how these arrays, links, text, keys work basically, and how we can write the code. So I'll like after this slide maybe I will share that code also, so that we can see how they basically work when we do the program. And the use of appropriate data structures also allows you to overcome some of the programming challenges, such as simplifying the complex problem, creating standard usable code components, and creating programs that are easy to understand and maintain. So these are the few of the things which you need to keep in mind while writing the code. Normally, we have these two types of data structures, basically. So we have a static data type and then we have a dynamic data type. And the two commonly used approaches for writing the algorithms, or we can say the programs, is like divide and conquer approach and the approach, right? So I'm going to explain these two also, because these are the two major things we are normally used while writing the program. Divide and conquer is a powerful approach for solving conceptually
now it is.
difficult problems. Okay. Yeah, Kedar.
Yeah, now I think he unmuted. So once you come to a logical end, please let me know. I'll share.
Sure, Kedar. Yeah.
Thanks, Abhishek.
Okay.
Welcome.
Okay, so then the divide and conquer approach, like we are breaking the problem into sub-problems and solving the trivial cases, combining the solutions to the sub-problems and solve the original problems. This is how normally we divide and conquer the problem. Then some examples of optimizing problems are finding the shortest distance. These are the examples that I just tried to show you. I guess everyone knows how we are using normally in our day-to-day life. This algorithm is basically working. So recursion, maybe this is also one of the common thing which I just like try to bring up, like repetitive processes basically. So when we have our codes written one time, we want to reuse them. So there are certain recursive processes which repeat and they work, right? So we normally try to use them so that our time could be saved while writing the programs, as well as the processes which we have already written, they can be reutilized. And since these are the repetitive ones, the same logic can be used and they can be updated, right? So here just say, like, I don't know, like, since we can mute or have interaction with the team. So this was just an example I was trying to see, like, this is a simple algorithm and we just wanted to identify, like, do we see any problem here in this particular algorithm. So it was just to return and find the sum of first and natural numbers. It's okay, like it's not interactive, then I can just move ahead. Because here we have not put any condition to stop this process, basically, seeing this algorithm. Because here we are trying to sum n, but when this n should be stopping, that condition is not here. So if you put that, then this algorithm should look like this, basically. So we have a check here now. I just showed in the beginning that there is check should be made, that 5 requirements for writing a program. The first one was the So this is just an example, small example. So these are the different factors which actually affect the efficiency of any program, right? So the speed of the machine on which the program or code is running, compiler which we are using, the operating system, the programming language, which we have used, like in which the programming code is written, and the size of the input, right? So these are few of the sorry, those are few of the factors which basically affect the efficiency of any programming language, program or code, basically. In addition to these factors, there are some programs that can affect the efficiency. So it's like the time and the space, basically, right? So the time, the CPU time required to execute the program, that is the time we normally consider. And space is like where actually the work code is saved and the memory, right? So these are also two factors which affect the performance of any of the program or code when we write it. This is one more thing, like time and space trade-off, basically. So if you want to reduce the time, then there should be less space. So that we have, like everyone is experienced, like as soon as our phone gets older and its memory actually pile up, the phone like starts slowing down. So this is kind of one of the simplest examples which everyone is facing every year, because almost in a year we have consumed almost whole of the memory, whatever is available in the phone, and gradually it slows down because it needs to store, it needs to search from that used memory for any information we need to figure out. So, right, and here the memory is extensible, but time is not. So that is also one of the factors which we need to see, because it keeps on extending. Right. So here, I just want to bring up, like, we can measure the efficiency of any program which we are writing, and for that, we have few notations which we are normally using, and there is one big O notation. I guess all the mathematical students who are from the math stream or science stream, they might know how this O notation works in. Just want to show here, like, these are the few O notation constants which we normally use. So here we have this constant, we have a logarithmic one, linear one, linear, quadratic, cubic, and exponential. They actually help us to identify, and then there are certain searching and sorting operations which actually works, and their efficiency can be measured on the basis of these algorithms. So we move to the next slide. These are the things I just try to cover up here. Like, algorithm has 5 important properties, which we just discussed in the first slide. Then we have like how we can achieve the maximum efficiency, and types of data can be static or dynamic. The approaches which we normally use for divide and conquer, and the grid approach. These are the two. And to increase the performance, we can use like, these are kind of two bottlenecks basically for anything. So time or space, they are dependent on each other. And total runtime, which we normally like divide on the basis of big O notation. We call it big O notation. This is the first part that I just covered, and then apart from that, I have some examples to show. So Kedar, would you like to continue this some part so that I can show the
Yeah,
algorithms later?
yeah. So I'll start
Okay,
mine.
thanks. Okay, thank you.
Thanks, Ram. I hope it is visible.
Yes, sir.
Yes.
Yes, sir.
Yeah. Good. Yep. So I think this we covered. I'll just quickly do it. So what we have done is, we just want to make a point. Data type has a type, and 3 is not equal to text 3. One sec. Yeah. So when this executable was like in we executed that and we invoked that, the executable was loaded into main memory, and since we asked for the variable I, this was given in a memory for us, and we entered the value 3. So the value 3 was given, and it was stored into this address. So the purple one, or the first line that is coming as address, that actually addresses are not like this. It is not very simple like 1234 or 1235 and all. Those are hexadecimal numbers, but here we have just represented for our purpose only, so that I'm whenever I wanted to have something to refer to. So the address given I have given is 1236. So memory location 1236 was given to me since my program asked for variable I and the value 3 was entered. So then one memory location 1, the first time it was given to 3. It showed 3 there, and when we executed the function, we got 9. But when we try to give 3, obviously it cannot hold the entire THREE, only in the memory space of only one location. It has given error, and if at all you want to store it, it will be stored like this. The point is, again, I mean, it will require 5 memory locations, and what we ask for is only 1, and that's why it errored. This did we cover? I mean, last time, Ram, if you are able to.
Kedar, actually, your screen was not visible during that time, and like it was a lag. So maybe you
Okay.
can continue.
So now is it okay?
Yeah, now it is okay.
Okay. Yeah. So the first thing what we're saying is, there are different data types, and each type takes up different memory locations in terms of sizing. The second point is the operations are not same. Why the data types are required? The operations are not same. A number and a number, 5 plus 4 will give you 9. If I take two strings, like I love is one string and India is a second string, and if I concatenate that, I'll get I love India. That is logical. But if I try to take 5 as a number, 4 as a number, and if I try to concatenate that as 54, it will go wrong. And that is why there is a need of identifying data in different data types when it comes to computer and computer memory. Okay, and the operations are just concatenation will not work with numbers, and addition will not work with characters. So this is just a list. I mean, it is not the complete list. There are many, but I've taken just for our understanding. The character takes of 1 byte. Example is A. Integer takes 2 bytes to store. Float takes 4 bytes to store. What we mean by float is 98.78. So if integer is taking 2, float has to take something to store after decimal point. So it is taking 4. And string is again just a series of characters. So if I have asked for string of 10, it will give me 10 spaces, and I can store. And those 10 are nothing but 10 characters I'll be getting. And again, string is not in many languages, string is not a data type. It is derived one from a character, and whereas in some programming language allows string as a data type. Internally, it manages to convert it into character. Yeah. Now let's look at the data structures. What are data structures? So data structures is a way of organizing data in order to use it in most efficient way. Is the page loaded, Ram?
No, it's still showing the DBT term.
Oh, I think some problem with my network.
Yeah,
Let
maybe
go
network
sleep.
is slow.
So now I'm on the slides where it is showing me what is data structure. Is it the same there?
No, still the slide number 29.
Let me know when it is refreshed. Is it refreshed?
So maybe you can reshare it. That will be great.
Let me say again.
Yeah, now it's reshared. Maybe data structures are on that page.
All right, I'll reshare again. As I've already come out of that, I'll just stop sharing and I'll share it again. Is it sharing now?
What is data structure? That's slide number 7.
7. It doesn't show me the slide number. Can you just read it, at least the title of that?
It is what is data structure? Data structure is a way of organizing data. That's what you can.
Oh, after that I've deshared it.
Data structure.
No, I've deshared now.
Oh, I guess it's taking some time. So because of that, I was almost 20 to 30 seconds to come up.
Yeah. So when it goes, please let me know. It should not be actually, because I've.
It has gone now.
Okay. Now I'll share it again.
Sure.
And let's go with the entire screen. Shared again?
Yeah, I can see what is data structure. That is
Correct.
the
Yeah.
definition.
I won't touch anything else. I think that's actually a problem. So data types is integer, character, string that we just saw, and there's a whole list. But what is a data structure? Data structures are nothing but methods of organizing and storing the data in the most effective way. So need of a data structure. For a better speed, using appropriate data structures can help fast searching of a data. For example, searching in sorted array is faster than the unsorted array. Memory management, it can help reduce the amount of memory needed to store the data. For example, using list over an array. We'll see that. We'll cover at least this couple of one array and linked list. I'm trying to cover in detail so that others we can understand easily. Faster data retrieval, like storage, we are looking at the memory. It should be stored. The data should be stored into the minimum storage. At the time while retrieving, it should be searchable fast. So that is a data retrieval. And better data management. It is easier to for multiple data. For example, stack can be used to implement for undo functionality. So what is stack? We'll see it again. And solving complex problem. So data structure can provide the foundation for efficient algorithm. For example, graphs can be used to find out the shortest path between 2 points. So data structures has basically two major categories. One is the primitive one, that is integer, float, character or string, and a boolean. And non-primitive, it is array, stack, queue, linked list, and tree, heap, graphs, hash. We're not going to cover all of this, but important of this we're definitely going to cover quickly. Is it on the primitive data structure now, Ram?
Yes, Kedar.
Okay. Yeah. So primitive data structures are basic values that cannot be further broken down. So integer, you cannot have further store it into something that I'll store only half the integer or kind of partial of integer. It has to be like whole integer or a character or a boolean should be stored as it is completely. They have fixed size and format. So once I say one integer, each integer will be stored regardless of its value in two memory locations, and then character will be stored in one byte or one memory location. They are built in, and they are used in almost all programming languages except few different, which is graphically which is used, which the applications are graphical and all. They may not be, it may not be required over there, but otherwise almost all transactional processing applications, they use it. These are the ones like integer, whole numbers, like minus 1, minus 30. Floats are with decimal points. Characters we already see. Then strings is a sequence of characters. Boolean is a separate one. I hope everybody knows, but just to just for their sake, it will have only two values, true or false. It cannot have a third value. So that is one. Non-primitive databases are complex. They are more complex, but they are more sophisticated. And non-primitive data structures are derived from the primitive ones. They emphasize structuring of similar data types. So what I mean by similar data types is if I'm coming of like characters, then the non-primitive data structures will continue with that type only, but it will give me some flexibility within that. So instead of storing at only one string at a time, I can go and I can store more strings of that type. Yeah. Then they are further divided into linear and non-linear. So let's look at that. The first one, collection of atom arrays, like collection of atom of the similar data types. So I can have arrays of integer or a character usually, and each atom is called element, and they are stored sequentially. So what I mean by sequentially is we'll see it in some time. Data type and numbers of atom must be declared in advance. So this is the problem with an array, that I have to guess when runtime, as a developer, when runtime, how much entries I'm expecting when whatever I'm defining this array for. And those contiguous memory locations are reserved once I declare and once I run the program. Each element has unique identifier, and that is called as index. So in a memory, when I say I want an array, this is how I declare the array. This is an integer array declaration, and the name of array is marks, and I'm asking for 4 memory locations for that. Actually, I'm asking for, with this declaration, I get consecutive 5 into 2 memory spaces reserved. Why 2? Actually, I'm asking for 5 because I've given 4, and 5 into 2. Why 2? Because each integer is going to take 2 memory locations. So with this, when I give the values like marks at the 0th one as like 91, index 0, 91, marks 1, the second element as 1 as 95, and so on. And please note, the first value is indicated by the array name and the index 0, not at as 1. So if you look at it, the memory location will be like this. And please note, it has taken, each of these is taken 2 memory locations. So 91 is stored into address 1234 and 1235. The next element with index 1 is 95. It is again taken 2 memory locations, and so on. I hope it is refreshing properly. So as with that, I'm giving now the third one, the next one, which is a character array. And you see the character array now, it is given me, and I've made some assignments also, like subject, sub kind for subject, I've asked for 4 memory locations, and 0th one I'm keeping like PCMB, and those are like stored into the addresses 1234, 1237. And here you notice now it has taken only one location. It is not taken 2 because the characters are stored in only 1 locations. Here now the point to be taken, or point to be noted is how array works is, so if the index is like on the second and I want to go to, or there are 100 locations and 100 elements are there, and my index is actually showing 97 and I want to come back to second or third, I don't have to come back one by one. So if I'm on 99th look,
Kedar, we lost your voice.
Sir, we are not able to hear you. Kedar, sir, just wanted to check if you are speaking because we are not able to hear you.
Oh, his voice.
you there?
Yes, sir. Yes, sir.
So can you please help me? What is shown on the screen?
Sir, there's nothing like it's loading as of now.
Oh my God. Because without the this thing, it's of no use. I mean, without the screen, it's no use. So shall I again de-share and share?
Sure, sir, we can do that.
Yeah. That's a problem, man. I don't know why. Abhishek, please help me when you are able to see what
Yes, sir,
are you able to
we
see?
can see the screen, sir, for the linked list, sir.
Yeah, but is it showing any memory graph also? With the text, it's actually showing some. It should show the memory graph as well.
Right.
Yeah, it's showing
On
there
the
in
right
the left
side.
hand side.
Yeah. Okay. So I think now it is done. So the linked list operate in this way. It starts. It stores what is the head address. So it is 1236, and then the first element is stored at a 1236, and 1236 the address part is showing 1236, and now the next is coming, like, the P is stored into the next atom, and in that the next value, it is indicating that the next value will be available at 2178. So if I go to 2178, I'll get the next element, that is where it is. So it is like value C, and to the C, the next element will be at 2489, and that will be M. The next element will be like, it will be showing as B value, and then at the B it is null. So it is, the null is actually showing me it is end of a linked list. So this is how the linked list work. I hope it is clear. And so this is a comparison between array and linked list, and then rest I'll try to cover a little fast. I will not get into much details. For arrays, the contiguous memory locations are reserved as per declared size, whether you use it or not. So there are chances that it is very difficult where your program will be used as a programmer. You really do not know, and how many entries will be actually required, how many elements to be declared when you're doing it, because it becomes a hard coding, and those hard coding cannot be changed runtime. But as opposed to it in linked list, the memory is not allocated from the beginning. The memory is allocated at runtime as each element is introduced. So if you are using with only 10 elements at particular runtime, it will utilize only 10 memory locations, or depending on each memory location, each element of a linked list, how many memory locations it is asking for. So this dynamic allocation helps managing the memory efficiently. New elements are appended at the end of an array. Not necessary always. You can programmatically change it. So it is an array of say 10, and 5 elements are already filled in, and you want to now go and insert into second. But the problem is then that it will lose the second value, the earlier one. So what you will need to do is you'll have to make some management first, and then shift the 5th value to the 6th location, 4th value to the 5th, 3rd value to the 4th, second value to the kind of 3rd, and then you can utilize the new value again. But that's a complex. So instead of that, in linked list, what can happen is you can just insert the element wherever you want just by changing the references. So if you just go here, you can just change the addresses to change the sequence, and you can just make a space to the new one very quickly. Abhishek or Ram, is it moving the screen as per what I'm talking?
No, it's frozen for us. Still on the link page.
I don't think we'll be able. There is a point to. Yeah, it is de-shared again. By automatically it is de-shared. 1 second. One second, I'm changing my.
Sure.
Kedar sir, we're not able to hear you.
I don't see Kedar in the screen. I will see for disconnected. Or maybe Abhishek, shall I show one program that I just wanted to show the team related to how the coding can be done for sortings?
Sure, sir, you can go ahead with the program, and thereafter we can conclude the session.
Okay.
Yeah.
Because it's only few minutes left. So
Right, sir. Right.
okay. Okay, so I just wanted to show one program like because I was not able to complete the initial part, and I just wanted to show like when we use this data structure. So the major things which becomes basically like how to retrieve the data fast from the database basically or any location where it is stored. So there can be certain sorting algorithms, there can be search algorithms. On the basis of that, we can find out. So here are few of the sorting algorithms like bubble sort, selection sort, insertion sort, cell sort, merge sort, quick sort, and heap sort. Considering like which one works faster in when the data is used, right? So on the basis of this, I just have one program here to share with the team. So just for the bubble sort, it's a small one basically. So as Kedar was saying, like you can define the integers or an array or different type of data type. So here we have a class here like the list one, and then we have defined a integer of type array, right? So this is just an integer. It's a data type basically. This is storing like storage capacity of this integer is array type is 20. So it can we can provide 20 elements to it, and it can store it on the array. So this is how we can define the variables basically. Then we had a function here. So I was also explained that we can break our program into small functions so that we can like increase the performance or we can make it more readable or more usable, right? So that if this function is required for some other operations, you can call this function in that place also. Right? So this function is created to read the values, right? So I just want to fill this array. So using this one, I can just fill the array and enter all the values to it. And as I said, like there should be some limit should be defined, like if it is going beyond elements or not. So for that, I just try to put here a condition on the basis of that. We can decide if it is exceeding the limit, then it should break and it will come out, right? So this was to get the value, and this is just to do the operation here, and this one is to display like whatever we have entered, the same values we can display on the screen, right? And this is the operation which we normally do to perform for the bubble sorting, like how the bubble sorting can be done, how we do the iteration from one element to other element, and how we search in that one. I have a actually presentation for this one, which actually try to explain how the sorting can be performed. But due to lack of time, I cannot complete this one. But yeah, actually, I just want to show you the program how it actually works. So this code I have just written in C Sharp, and it can run on any. It's similar in Java also. Like the syntax wise, it's almost the same. So I just try to run this one. So when we run the program, it will request us to enter the elements in it, right? Since we have defined a size for this code, like it can enter these many values, right? So when we try to enter the values, it's asking us to enter the elements into it. So I will just define, like, I just want to put 5 elements into it, and then it will ask us to enter some values into it. So I can put some random number. Put 5, it has taken 5 input values and it did the sort operation. So it's did a bubble sort basically, right? And on the basis of that, it has given this output to us. If you can see here, like see here, like so. This one just was performed to get the values, and this value came into array elements. This is what let's try to put it from here. So this is how we can format the program and give instruction to the machine that how it needs to display the data or how to operate it. So it has a condition here. Then it input all the values here, and this give the input from the console application, and this give the type conversion here with the element, because if we try to, since we defined here the data type as an integer, if we try to put any other data type like the string or any other character, it will not accept and it will fail basically, right? So those were the things which we just tried to explain in the beginning, that the data type should also be in the proper format. And if we try to put the wrong data types, then it may not work and the efficiency will decrease. Stop in between. And then this is just a function to display the values, like whatever values we have sorted. So it is going to display this function. But yeah, before displaying, it need to sort the data. So this is the function basically which is trying to sort the data. So we are iterating from element number 1 to element number 5, right? The last element which we have this. So 2, 8, 3, 1, 9. So it actually did the iteration with all the elements which went there, it swapped the values, it organized it, and then finally after organizing it has given this one. So similarly, we have other different perform, and this was my main function where I just called my function. So I just created my list, I read the list, I did the sorting, and then I did the display part. So now if you want to exit from here, I just need to press any key, and then I can exit from this code. So similarly, I had few more functions, but lack of time, maybe we cannot cover it up. So this was just one of the examples that I wanted to show. Over to you, Rishabh.
Thanks a lot, sir. It was really nice getting such valuable insights and exposure in the field of database and data structures. I would really appreciate you taking out time and Mr. Kedar, sir, from TCS for sharing such valuable content. All the participants, we hereby conclude the session. Request you to kindly join the further sessions lined up for this week. These sessions are really insightful and provide great knowledge from the industry experts, such as Tata Consultancy Services. Thank you all. You may leave the session.
Okay. Thank you all. Thank you, Dean. Thank you, Abhishek.
Thank you, sir.